Yo guys, I've been talking about the beauty of Maclaurin series for a while now. And then in today's video, I want to show you, we already know this concept that the limit of x approaching 0 of sine x over x is always equals to 1. But do you know why? You don't know why. But in today's video, I'll be showing you the secret behind this. And I hope you guys will be happy to know the secret behind this. Okay, and then I'll be applying one of the beautiful concept, one of the beautiful principle to this. I'll be making use of the Maclaurin series, okay, and also make use of the L'Hopital's rule, okay. But the first thing I will do is the Maclaurin series because I want to show you how beautiful it is, okay. So don't forget, Maclaurin series says that here's what it states. Says that f of x equals to f of 0 plus f prime of 0 multiplied by x plus f prime prime of 0 multiplied by x to the power of 2 over 2 factorial, okay, plus f prime 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 of 0, okay, multiplied by x to the power of 3 over 3 factorial plus dot 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 dot. Okay, that's awesome. That's awesome. Now, in this case now, of course, our f of x is now equals to sine x, okay, equals to sine x. Yeah, because I want to find the series expansion of the series of sine x. That's what I want to do. That's what I want to find. That's why my f of x equals to that. And then if my f of x equals to this, I need to look for f of 0, and f of 0 will be sine 0, and sine 0 equals to 0. Okay, f prime of x will be the derivative of sine x, which is cos x. And then f prime of 0 now is cos of 0, which is equals to 1. All right, let's find the third derivative of x, which is equals to minus sine x. Okay, f prime prime of 0, of course, now will be equals to 0. Okay, that's cool. And then the fourth derivative of x, I'm going to the fifth derivative. Okay, if I differentiate this, I'm going to have minus cos x. Okay, f prime prime, oh sorry, this is f prime, this is f prime prime, this is f prime prime. Okay, so I'm going to have f prime prime of 0 to be equals to minus 1. That's cool. And then the f prime prime, the fourth derivative of x will be equals to sine x, and then the fourth derivative of 0 will be equals to 0. And then the fifth derivative of x, of course, now will be equals to cos x. And then that will be the fifth derivative of 0, which is equals to cos 0, which is 1. That's beautiful now. Okay? All right, let's move on. So now, I want to substitute this value into the Maclaurin series, which is from here, which is f of x equals to f of 0 plus f prime of 0 multiplied by x plus f prime prime of 0 multiplied by x to the power of 2 over 2 factorial plus f prime 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 of 0 multiplied by x to the power of 3 over 3 factorial. Okay, plus, let's say dot dot dot. It continues like that. Now our f of x is sine x. You can memorize this. You don't need to solve this. For example, in your exam, you don't need to pass through all the stress. You can memorize sin x. Sin x is going to give us x minus 3, x minus, x minus x to the power of 3 over 3 factorial plus x to the power of 5 over 5 factorial minus x to the power of 7 over 7 factorial. I know that already, but I just want to show you how we derive this. So in your exam, you can memorize what we mean by sin x, cos x, this power series of sin x, cos x, the sin x, the cos x, the tan x, tan inverse of x. All these things, you can have them in your memory, in your brain. Okay, so now let's continue. So f of 0 is equals to 0 plus f prime of 0 is 1 multiplied by x plus f prime prime of 0 is 0, okay, multiplied by x to the power of 2 over 2 factorial plus f prime prime of 0 is, of course, minus 1 multiplied by x to the power of 3 over 3 factorial. I won't stop here. I'm going to the fifth derivative, okay, plus 0 multiplied by x to the power of 4 over 4 factorial plus, okay, 1 multiplied by x to the power of 5 over 5 factorial plus dot dot dot. Okay, so that's where I want to stop now. Okay, now let's continue. And then this means that this implies that sine x, of course, will be equals to 0. 0 doesn't have any value. So 1 multiplied by x, I have x. 0 multiplied by this is still 0, okay? Minus 1 multiplied by this, I'm going to have a negative x to the power of 3 over 3 factorial. Okay, this is 0, and then I'm going to have plus 5x to the power of 5 over 5 factorial, and then plus dot dot dot. Now, do you know my question for you guys? Okay, what will be the next 5 terms of this series, the next 3 terms of this series? Find the next 3 terms of the series. Find the next 3 terms of this series, and let me know what you have. Let me know the output in the comment section. The next 3 terms of this series, let me know. Okay, now, but I'm not going there. Let me get back to my problem that says as the limit of x approaches 0, okay, of sine x over x. This is the problem again. The limit as x approaches 0 of sine x over x will now be equals to, since I already know the value of sine x, so my sine x is x minus x to the power of 3 over 3 factorial, okay, plus x to the power of 5 over 5 factorial plus dot 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 dot, okay, all being divided by x. All right, so this is what I'm going to have, okay, the limit as this approaches 0, okay, the limit as x approaches 0. It's very essential to remember that. All right, now let's continue. That implies that we are going to have a, x divided by x, that's 1, minus x to the power of 3 over 3 factorial divided by x is going to be x to the power of 2, okay, over 3 factorial, okay, plus x to the power of 4 over 5 factorial plus dot 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 dot. But we are still going to find the limit of this as x approaches 0. Don't forget, as x approaches 0. So therefore, the limit as x approaches 0 of sine x over x, okay, equals to, now wherever we see x, we write 0. We're having 1 minus 0 to the power of 2 over 3 factorial plus 4 to the power of 0 to the power of 4 over 5 factorial plus dot 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 dot. Okay, that's awesome. That will be equals to, everything here will be 0 0 and continue like that, so equals to 1. So that's how we obtain 1, and I hope you get that now. All right, so I will make use of the law of Peter's rule to quickly solve this problem within a seconds, within the blink of an eye. Okay, wait for me. Okay, now in this section I would like to quickly brief something for you. Whenever you want to find a limit of a function, the first thing to do is to make use of direct substitution. Make sure you make the first thing you do is applying the making a direct substitution. So if that doesn't work, or it give you an indeterminate function, you get what I'm saying? Okay, that is having 0 over 0. Okay, then you are going to check the L'Hopital's rule. You are going to check the L'Hopital's rule. Is the fastest route to finding the limit of a function. Okay, and if you understand the power series very well, you know them offhand, it will also be better to make use of them. You can see I've made use of the power series now, using the Maclaurin series. Okay, now in this case now I'll be making use of the L'Hopital series, and then that will be, if you differentiate sine x, I'm going to have cos x. Don't forget we are taking the limit over 1. We are taking the limit of the limit as x approaches 0 of cos x over 1 will now be equals to cos 0 over 1. And what's cos 0? Which is 1 over 1, which is equals to 1. So thank you. See you next time.